So far we have seen one construction of ellipse where we took two fixed pins and a piece of loose string that was tied to them. Now we'll see if something like that can be used to trace a parabola, which is after all a conic like an ellipse. For that we will start with its basic definition, where we have a fixed line and a fixed point. Together they are defining the plane of the parabola. Now we are going to take a point such that its distance from the fixed line is same as its distance from the fixed point. Then such a family of points, such a set or such a locus, is going to give us the parabola. The fixed line that we had is called as the directrix, and the fixed point is called the focus. And the distance of our tracing point P from the directrix and focus D and F, they remain equal to each other all the time. Now suppose we draw an arbitrary line parallel to the directrix, and suppose its distance from this current position of point P is say L. Then D plus L must be constant, because that is the distance between directrix and this line. So D plus L is constant. But D and F, these two distances are the same, so we can substitute F in place of D, giving us expression F plus L is equal to constant. So we have two lengths adding up to a constant, and both are measured from fixed entities. F is measured from a fixed point, while L is measured from a fixed line. In such a case, we can think of using a string of constant length. At one end, it will be tied to a fixed point, say a pin, and at the other end, it will be resting on a line, a fixed line. So you can think of this line to be some kind of guiding bar, like one we use for hanging curtains. So there will be a ring going in the bar, and this is, imagine, your curtain. So it will be able to slide on this bar and still remain perpendicular to it all the time. Let us see the physical arrangement. So here we have the physical model. So we'll rotate it to get a better view of this, like this here, and we will zoom in to take a closer look. Maybe we can change our display like this, that's better. So if you zoom in here, you will see this is our rod in which this pin is engaging. So it is capable of sliding back and forth like this. So I can take this curtain and move it. Okay. And as it moves, you will see the pencil is moving. Over here we have this pin, which is our focus. So let us see what kind of curve it traces. So I'll just move our pencil. This is the curve it is tracing, which is indeed a parabola. So this is the string and pin method of drawing a parabola. Or if you compare it with the method for ellipse, then this is one pin and the other pin is on this line at infinity. It has gone too far away, we can never see it, and that is where this other pin, other piece of string is pointing, and therefore these two segments of strings always remain parallel. Now one last difference that I have made here, that instead of taking a piece of string that goes from this ring to the pencil and to the fixed pin, I have added this additional piece with an additional ring, so that when our pencil crosses over from this point to the other side, one say ring stops and the other starts sliding. So we have a smooth transition from one half of the parabola to the other.